Welcome to our next lesson. This lesson is 9.1.3 called Exterior Angles in Triangles. Um, what we're going to learn about today is something really interesting that happens with angles of triangles when you extend one of the side lengths. Triangles have three sides and three angles, but if you extend one of the side lengths, there is a pattern to the measure of this angle that is created by extending one of the sides. So today we're going to work on that. We're going to do some problem solving involving this concept. So exterior angles of triangles. The exterior angle of the triangle is this angle right here that is on the outside of the triangle, and it is created by extending one of the side lengths. Okay, so um, this is what we're going to be figuring out how to find out what the measure of that is. Now, some of you, because you understand how supplementary angles work, you already know how to find out the measure of this angle. But I'm going to show you that if we don't have this piece of information right here, that this is a 60-degree angle, there's still a way that you can figure out what that angle's measure is. And it involves knowing what the two remote interior angle measures are. So let's take a look at this definition. The remote interior angles of a triangle are the two angles that are on the inside. Notice how we have three of them, but two of these that are on the inside or interior of the triangle that are the farthest away from the exterior angle. So if the exterior angle is here, this one is the angle that's closest to it. It's actually adjacent. So the two other ones, this angle here and this angle here, those are your remote interior angles. Before we get started on this concept of remote and exterior angles of triangles, it's really important that we review how to name an angle. Now, if you look at this triangle here, notice how you've got the vertices of the triangle are X, Y, and Z, and the angles on the inside are designated as A, B, and C. When you've got a triangle like this, you could just call this angle A, this angle B, and this angle C. But as you can see from my figure that I've got drawn in here, if you've got multiple angles that come out of an intersection point, I can't just call one of these angles angle A. There's got to be a more specific way to determine which one is angle A. Is it that one? Is it that one? Is it that one? Or is it this one? Just identifying the point doesn't do it. So there is a process that we use when we are trying to name an angle where we use three letters instead of one. So let me show you how we would do this. So if I take angle A and I wanted to choose, say, this angle right here. This angle is made up technically of this ray and this ray, where A is the vertex of that angle. So we're going to have A be in the middle of it. And then this ray goes through point E, and this ray goes through point F. So we're going to put those 2 points on either side of our vertex, and then we're going to call this angle AEF. If I come down to, say, this angle right here, I can't just call that angle B because that is angle B and this is angle B and that's angle B. So I need to use three letters. So B is our vertex. So I'm going to put the B in the middle. And then we take the two rays that make up that angle, and this ray passes through point G, and this passes through point A and point F, and you can choose either one of them. I'm just going to choose A. And so this is angle GBA. So this is using the three-letter format for naming angles when you've got multiple angles coming out of the same point or the same vertex. So with that in mind, what we want to do for this activity right here is find another way to name angle A, another way to name angle B, and another way to name angle C. Go ahead and pause it and work through that. See if you can figure out, using the technique that I showed you here, see if you can name those three angles another way. Okay, hopefully you've done it and you unpaused. And let's see with angle A, that's this angle right here. And so the vertex for that is Y. So that's the point that's going to be in the middle. And so it technically doesn't matter if we go X, Y, Z or Z, Y, X. Either order is fine. Hey, what happened to it? Oh, I erased boo. Let me pause. I'll get them right back. Okay, we're back. Sorry about that little mistake. So yeah, angle A, where y is the vertex, could be called xyz or zyx. It does not matter which one is at the beginning. You can reverse these two, but the y, since that's the vertex, has to go in the middle. Write that down. That is the rule. For angle B, this is angle B, where x is the vertex, so x has to go in the middle, and it can either be yxz or zxy, as long as the x is in the middle. And angle C has a vertex of point Z, so Z has to go in the middle, and it can either be yzx or xy, no, xzy. As long as the Z, the vertex of your angle, is the letter in the middle, that is going to be properly named. Okay, so here on this page for problem number 28, it shows you the definitions and how you would name some different angles. Um, Sometimes it's a source of confusion of what represents an interior or an exterior angle. So remember, one of the side lengths has to be extended for this to be considered an exterior angle. You're extending this side, there's the exterior angle. You're extending two different sides, so you've got two different exterior angles. You're extending this side, that's exterior. Extending this side, that's exterior. This right here is not an exterior angle. The exterior angles would be either here or here. So one thing that's important about the exterior angles is they have to be adjacent to one of the angles of the triangle. This one here is not adjacent, it is vertical, so that would not work as an exterior angle. This is not an exterior angle because it's not an extension of one of the sides, and neither is this. So you're extending one of the sides of the triangle, and the exterior angle would be adjacent to or supplementary to one of the existing angles of the triangle. Okay, so this is what I'd like for you to do. I'm going to pause the video. What I want you to do is identify in every single one of these angles. Here's angle A, angle A, angle A, and angle A. Please record for each one of these figures the measure of angle A, if you know it. If you don't know it, just leave it blank for now. Then let's find angle B and find the measure of angle B for each one of these situations. Once again, if it's given, write it in. If it's not, leave it blank. For angle C, this is a little bit tricky because you've got two different angles in angle C. So the interior angle of angle C, in this case, is going to be ACB every single time. There's an interior angle. ACB, here's an interior angle. ACB, here's an interior angle. And ACB, this is an interior angle. So all the interior angles for angle C get written in here. And of course, the ones that you don't know, leave them blank for now. And then for angle BCD, that's going to be the exterior angle for each one of these. BCD is this one. BCD is this one, and BCD is this one. Okay? See if you can figure out, just using what we've learned so far about triangle sum theorem, try and figure out in supplementary angles, see if you can fill in every single one of those. And then once you've filled them in, please add the measure of angle A and angle B and see if you notice any pattern. I'm going to pause the video. You go ahead and pause it. And when you come back, I'm going to have all of these filled in. Hopefully you will have them filled in as well. Alrighty, so a couple things to be aware of. Angles A, B, and ACB are the three interior angles of a triangle, so they are going to have a total sum of 180 degrees all the time. We also know that angle ACB is supplementary to angle BCD, so these two have to be supplementary, which means they have a sum of 180 degrees. Angle angle BCD is the exterior angle, and then these two make up the remote interior angles, angles A and B. So with that in mind, I'm going to go ahead and move this off to the side. Everything that was given, I wrote in red. Everything that I figured out by using a little bit of algebraic reasoning along with supplementary angle theorem and triangle sum theorem, I wrote in blue. Now, what are you noticing about these two columns here? Are you noticing that the sum of the two remote interior angles is always equal to the measure of the exterior angle? Happened in every single one of those figures. So that is the big idea for this lesson. When we get down here to problem C, write a conjecture about the relationship of an exterior angle to the two remote interior angles. That conjecture is the exterior angle of a triangle is always equal to the sum of the two remote interior angles. That's a rule that we're going to have to pay attention to, just like the rule for supplementary angles and just like the rule for the sum of the three angles of any triangle always add up to 180 degrees. So with that the case, let's go ahead and pause and see if you can answer the questions A and B for this figure. While you're doing this, I cannot state enough how important it is for you to draw these figures into your journal. Label everything. Geometry is a very visual mathematics. It's really important that you draw these pictures and you label everything as you go. Don't try and just write things down and solve them and don't record the full images, because when you go back into your journal, you're not going to know what it originally looked like. Right now you know what it looks like, but you won't know tomorrow or next week. So draw these images in. Okay, pause if you need to. Come back to me in a second. Okay, so let's see. If angle 1 is 53 degrees and angle 2 is 71, then we know angle 4 has to be the sum of those two angles. So you should have said this has to be 124 degrees. So we can now figure out what 3 is, because we know triangle sum theorem, the three of them add up to 180. So these two plus that equals 180. But we also know that this plus that equals 180 because they're supplementary angles. So you can figure out what 3 is as well, even though we're not going to do that. We don't need to for this problem. Now we know that angle 2 is 78 degrees, and we know the exterior angle is 127. So now we're going to use some algebraic reasoning to solve for angle 1. Subtracting 78 from 127, and you should get 49 degrees. All right, problem 30, once again, pause, use some algebraic reasoning. I'm going to go over these very quickly, and this will end our lesson. Okay, you're back. Hopefully you took the time to work through all of these problems. Let's look at triangle A. So triangle A, these are the remote interior, so the sum of these two is going to be equal to 135. So that means that 5x's is 135, and our goal is to figure out what 1x is equal to. So let's go ahead and divide each side by 5, and you should have gotten x is equal to 27. For this, we know that these are the two remote interior angles, and this is the exterior angle. So 3x minus 1 plus 21 has to be equal to 167. Combine like terms, remove balanced sets. We're going to take away 20 from each side. So 3x's have to equal to 147, which means 1x would have to be equal to 49. For triangle C, these are the two remote interior angles, so we're going to add those together, and they will be equal to 2x plus 30. So that means that 74 is equal to 2x plus 30. Now we'll subtract 30 from each side, then divide by 2. That means for triangle C, x had to be equal to 22. All right, make sure you're showing all of your work. Good luck on your homework tonight. I will have a check for understanding for you to see if you're understanding the basics of this. Thank you to all of you that have been doing the checks for understanding. That really helps me understand who's understanding this material and who is not, and it should also be helping you understand what you're doing wrong. I'm pretty sure you're able to see what the correct answer is and whether or not you're getting it right or wrong. Remember, the checks for understanding are not hurting your grade or helping your grade. It's just information. It's just feedback for you. So good luck on everything, and do your best on your homework.